Hi everyone. So today we'll be starting with our second chapter, that is enamel. Enamel is divided into the following topics, and today we'll start with the physical and chemical properties. Okay. So physical properties, enamel forms the protective covering of variable thickness over the entire surface of the crown. So we know that if this is a tooth, the outermost covering of the tooth is called enamel. It is thicker on the lingual surface of maxillary molars and buccal surface of mandibular molars. So what happens is that this is your maxillary molar and this is your mandibular molar. Okay, so the enamel will be thicker over here and over here. And why so? Because these are the functional cusps. Okay, so when we chew, these are the main cusps that come in contact and they help in chewing. That's why enamel is thicker on these two cusps. It is brittle in nature and the modulus of elasticity, sorry, just a second, yes, it is brittle and modulus of elasticity is greater at the surface than the dentino-enamel junction. So it is just a property that it is brittle in nature, so it can be broken into pieces easily. Not easily, but it breaks down into pieces. And modulus of elasticity is greater at the surface than dentino-enamel junction, so it is more rigid on the dentino-enamel junction. Dentino-enamel junction is when the where the enamel meets the dentine. Okay, so this is the crown and this is the enamel and this is the dentine. So this junction where they meet is called the dentino-enamel junction. The specific gravity of enamel is 2.8. Density decreases from cervical to incisal region and surface to deeper region. Okay, so the density is more on the cervical region and the uh, inner uh, inner regions of the tooth. Okay, it is an insulator at room temperature. It is semi-permeable in nature. Color of the enamel covered crown ranges from yellowish white to grayish white. The variation is due to difference in degree of calcification. What happens is that the enamel doesn't have a color of its own. Okay, so the enamel, so if this is your tooth, the enamel doesn't have a color of its own, and slightly it will show the color of what lies underneath it slightly. So the dentine is yellow. Okay, and enamel is thicker in this region, but going down it will become thin. So that's why when we have this, so this is kind of what the enamel will look like. Okay, and going down it becomes thin, so your teeth appears yellow in the downwards region. And on the surface, on the not on the surface, on the incisal edge there will be no dentine. Okay, so the enamel is generally seen as a blue line on the incisal edge, not blue, mainly grayish line, because there is no dentine. So the enamel will be yellowish in the cervical region, and there is a gray or bluish line on the incisal edge because it is translucent. Now coming to chemical properties of enamel. Chemical properties, so it has 96% inorganic material and 4% organic material. What is the inorganic constituent of enamel? So the enamel, the inorganic constituent is hydroxyapatite crystals. Okay, this forms the entire mass, the inorganic mass. This is the formula of hydroxyapatite crystal, and they form enamel rods. Okay, so enamel rods are something like this. These are hexagons, and uh, they will grow like this, and these are enamel rods. Okay, and so this is the base of that hexagon, that enamel rod. Imagine this was the rod, and this is the base is in the form of a hexagon. So this is the base, and this is the structure of hydroxyapatite crystal, which will form the enamel rods. Now coming to the organic content of in the enamel, contains 90% amelogenes and 10% non-amelogenes. These are proteins. Okay, so in the organic content, it contains proteins, and the 90% are amelogenin proteins and 10% are non-amelogenin proteins. Amelogenins are heterogeneous in nature. They are of low molecular weight, they are hydrophobic, and they are rich in proline, histidine, glutamine, and leucine. Whereas non-amelogenins, they are of high molecular weight, they are rich in glycine, aspartic acid, and signin. And the examples are enamelin, tuflin, and ameloblastin. This can be asked in the viva, which is sometimes important. Okay, now water. Water is present as a part of the crystal, the hydroxyapatite crystal, in between the crystals and between the rods and surrounding rods. So basically, if I have an enamel rod over here, and this is composed of this crystal, right? So there will be, uh, I'll just draw it using a pen. So this is my enamel rod, and these are the hydroxyapatite crystal. So water will be present in between the crystal, obviously not in so much amount. It will be present in between the crystals, between the rods. So there's this rod and there is another rod. So it will be present in between the rods and surrounding the rods. Okay, so basically outside the rod as well, water will be present. Pores are present between the crystals, especially in the boundaries of the rods, and these are filled with water. So there are some pores in here as well in the rods, and they will be filled with water too. Enamel proteins do not contribute to structure of enamel, in contrast to collagen, which is the principal protein of dentin or bone, having a structural function. Okay, so enamel proteins, when I have these rods right in the structure, so these rods form the main structure of the enamel. Enamel proteins will be mainly a part of the matrix. They lie here and there. So they don't have any function with the structure of or strength of the enamel. Whereas collagen, uh, it provides strength in most of the tissues we'll study further. So there is a contrast between the proteins present in enamel and the protein which is collagen, which will be present in the dentine or pulp or bone, sorry. Now coming to structures of enamel, I will cover all the structures of the enamel in next video, but for now I'll just teach you the rods and the ultrastructure of enamel. Okay, so what is enamel composed of? This is the crown. Okay, enamel is composed of these rods. Obviously, this entire space will be filled with rods. And what happens is, so there are three components to enamel. First is this enamel rod. If I zoom into here, first is this enamel rod. Second is the rod sheath. So you see this greenish thing, it is covering the rod. So this is the rod sheath. And third is interprismatic enamel. So when enamel is formed, there are two components formed by the ameloblast. One is the enamel rod, and second is the interrod material, which is the interprismatic enamel. So it basically fills in the space between two rods or multiple rods. Okay, so this is what said the enamel consists of enamel rods or prism rod, rod sheath, and interprismatic substance. Number of rods ranges from 5 million in the lower lateral incisor to 12 million in the upper first molar. So obviously the lower lateral incisor is the smallest tooth, so it will have the least number of enamel rods, and the maxillary upper first molar is the largest tooth, so it will have the most number of enamel rod, that is 12 million. Rods run at a tortuous course from the dentino-enamel junction to surface. So what it means is that enamel rods won't go like this, okay? They won't go straight. They run in a wavy kind of fashion, and they start from the dentino-enamel junction and they end at the surface of the enamel, obviously. They form the enamel. Rods located in the cuspal region are longer than the ones located in cervical areas. Okay, so this is very much common sense that if the cervical area is thinner, so the rods over here will be shorter and the rods in here are longer in the cuspal region, because that the cusps are higher up, so the rods in here will be longer. Rods look okay. the average diameter of the rod is 4 micrometer. However, it varies throughout. It is near the dentino enamel junction. It is thinner than the surface. So I have drawn in this diagram. The average diameter is 4 micrometers. Okay, but when the rod starts in here, it is thinner, and then it keeps getting thicker over here. The Because there is more surface area over here, so the rods will be thicker. And if I take the diameter, so I have zoomed in over here, right? So if the area of this portion is 2, the area of this portion will be 1. So at the dentino enamel junction it will be 1, and in the surface it will be 2. So this is the ratio of diameter, so not the area, it is the ratio of the diameter at the dentino enamel junction to the surface of enamel rods is 1 to 2. Okay, so it is twice as much thicker on the surface than at the dentino enamel junction. So these are the enamel rods. Now coming on to the ultrastructure of enamel. What is ultrastructure? It is what's seen under a microscope. So many minute structures, and like details of the enamel rods I'll study in here. Enamel rods appear to be like fish scales or keyhole pattern under light microscope. So when a picture of enamel is taken, it appears kind of like this. I should have inserted a picture. So it will appear like this under the microscope, like fish scales or keyhole pattern. Why it's called a keyhole pattern, I'll explain right now. They measure 5 micrometer in breadth and 9 micrometer in length. Striation appears. Okay, so I'll explain this first. So I had this ground. Okay, I took a picture of this, and it appeared kind of like this. Okay, so this is the ultrastructure of enamel. This is how the rods look like under the microscope. Why is this called a keyhole pattern? You see this shape, right? This is one enamel rod, this thing, and it appears like a keyhole. Now there are also some striations visible. Okay, so if I take a picture over here, you will see there are two kinds of substance. Okay, one is this and one is this. So this is interrod material. Okay, the not this, like this line and this whole area. So this is interrod material, the line, and then this whole area is enamel rod. So these two different substances, they give rise to striations. So striations appear in the ultrastructure of enamel. Now what else is happening? Uh, so I just wrote that striations appear due to placement of rod and or interrod substance in alternate positions. Now there is one more type of striation, that is sorry, that is cross striations. Just a second. So there is this another type of striation, that is cross striations. And what are they? So if I take this enamel rod out in here, and I view it from this side lengthwise, so this is the head. Okay, so there are some striations on the enamel rod itself, and these are called cross striations. And how are they formed? They are formed because of the formation of enamel. So if it is a rhythmic deposition, so the enamel formed, and then there was a period of rest, and then it was formed, and then there was a period of rest. So that period of rest, in that period of rest, there is still enamel forming, but it has a slightly different consistency to the enamel that was formed in the active period. So that's why it appears darker, and they give rise to cross striations in the enamel rod. And these will be visible otherwise as well. Okay, enamel rod due to rhythmic enamel formation. So this is what's written over here. Striations appear due to placement of rods and interrods in alternate position. Cross striations within the enamel rod due to diurnal rhythm in enamel formation are also present. Now, the enamel rod, what is this made up of? Okay, Now, oh, this contains hydroxyapatite crystal. Okay, if I cut over here, so there will be like one crystal over here, one. So this is made up of hydroxyapatite crystal. It lies parallel to enamel rods. You had seen in the previous slide that that was hexagonal in shape. Okay, so hydroxyapatite crystal. This is a hydroxyapatite crystal. It lies parallel to the enamel rods. Deviation of up to 65 degrees can be observed. So generally it's parallel to the enamel rods, but it can be sometimes it might be tilted slightly up to 65 degrees. Okay. Organic matrix forms an envelope around the He crystal. So whatever we had, there was only 10% organic material, sorry, 4% organic material, and that organic material forms a kind of a sheet over this hydroxyapatite crystal. This is where the organic material lies. It may also exist in between the crystals. So there is one crystal and then there will be organic material, and on top of this there will be another crystal. So organic material lies around the crystal and on top of the crystal, or below the crystal. Okay, so this is the ultrastructure of enamel, and I'll start from incremental lines of its size from the next video.